Alright, so we eliminated the hydrogen, and I'm going to erase these. Sorry, I had to re-record this one. Now I'm going to look for anything else that's found on both sides. The only thing is going to be this carbon. Now I have one on the left side, so I can cancel out one on the right side, which means I'm still going to get one carbon in my product. And now we're going to add everything up again. If we look at our steps, I need to check the number of moles and then multiply or divide like the moles of the whole reaction as well as the delta H values. So if I look, I'm going to find that I am off on F2 because I need 6, right here. I have 3. I am off on HF, 2HF. I need 4 right here, right? 4. CF4 I have 1, and here I need 2, okay? And then it looks like I have excess carbon and H2 the way that I did it. So now I'm going to have to multiply some of these equations. Now, let's focus on 3F2 and try to get that one. So up here we have F2 in each of the first and second equation, and just talking through it real quick, if we were to multiply this, say by like 2, that would give us 4F2, and we have 1F2, and that would only give us 5F2 total. And if we multiplied it by 4 and then this one by 2, that would give us, well, by 2 and then actually, sorry, that's what you're supposed to do, but let's look. So if we did this one by 3, that would give us 6 and then a 1, and that would be 7F2 total. That's not what we want. If we did this one by 4, that would give us 4, and 2, if we didn't multiply this one, just kept it at 1, well, 2F2, we would get 6F2, but this would then become 8HF, and that's way more HF than we need. So let's do it that way that I accidentally said before. So let's multiply. I'm going to put the multiply 2 over here so I don't forget to multiply the delta H value. And I'm going to multiply this one by 2 as well. And that's everything. So remember, I have 2, that becomes 4, 2, 4, and 2, and then now let me multiply these values. So 690 becomes -1380, and 537 becomes -1074. Right? Okay. And so at this point, what I'm going to do is I'm just going to re-add up the equations. So like I'm starting here, I basically restart and then see if I can cancel these out. I'm not going to start from here because I would just get so messed up that I'd lose my place. So what I'm going to do is take all of this and just straight up move it out of the way. I'm going to throw it over here, okay? So now what I have is I'm going to have 2H2 plus 2F2 plus 2C plus 4F2 plus, remember, this is the reactant now, C2H4 goes to 4HF plus 2CF4 plus 2C plus 2H2. Alright, so I have this full thing. I added everything up, and now I can cancel anything out that's found on both sides. And it just so happens that this time, look at this beautiful 2H2, 2H2, those cancel out. 2C, 2C, those cancel out. And that was the carbon and H2 that we had excess of the first time. And we're going to need to add these together. And I believe that's it. So we have 2F2. Oh, sorry. 2F2 plus 4F2, which is going to give 6F2. Alright, that's right here. Plus C2H4, that's right there, goes to 4HF plus 2CF4. Then everything else is canceled out. Now let's look. Now that's okay, like this comes first, that comes second, it doesn't matter as long as these are on the reactant side and these are on the product side, similar with this. So we have C2H4 on the reactants, C2H4 on the reactants, 6F2, 6F2 on the reactants. Then we have 4HF, 4HF on the products, 2CF4 and 2CF4 on the products. And so that's, we got the equation right. Now let's look at our values. So remember we flipped this third equation so that it's, I'll just write it right here, negative 52.3, and these are all kilojoules, okay, up and down. And then I am just going to add those together. So 52.3 plus 1380 1074 equals negative 2506.3 kilojoules. And then our delta H of, not of that reaction, right? This one equals negative 2506.3 kilojoules. Awesome, guys. We know if you have any questions, but good job.